Hello friends. So today we are going to find the area of the heart curve. As you people can see, I have written the equations of the heart curve. Let me put the equation of the heart curve in the graphic calculator Desmos and let's see how the curve originally looks. Let's try. Sorry, this is mod x. Mod x. This part will be created. So this is how a original heart curve looks like. As you people can see the green, this equation, which is the graph of this green, and this is the part of the green part. This is the green part and this represents this equation, and the blue part, this represent this equation, the first equation, and both these two equation combines the heart curve. At a first glance, we can comment one thing, that this curve is symmetric. Symmetric about what? Symmetric about y axis. See, this axis, this is called this y axis, and about y axis, this curve is symmetric because this part is same as this part. So, in order to find the area of this curve, if we find the area of this part and multiply it by 2, then you can find the whole area, right? So today we are going to do that calculation. Let's see how it goes. So now to the calculation part. So we have to integrate this first function y equals to root under 1 minus mod x minus 1's whole square in the range from 0 to 2, right? But see, there is a mod x part. The mod x part simply represents the symmetric part. As we are doing the calculation on single part, so we are taking it as x. So let's do it. Let me change the color of my pen first. Okay, it will be easy for me to do it. Okay, then. So we have to integrate 0 to 2, in between 0 to 2, this guy 1 minus x minus 1 whole square dx, right? The first thing what we can do is we can put x minus 1 as, say, u, then dx is equals to du, and then our integration simply changes. I will come to the limit part after some time. Okay, now if we change the variable of the integration, it becomes simply 1 minus u squared du. We are doing this type of integration from a long time, and we are doing this by simply putting u equals to sine theta, then simply du equals to cos theta, right? And if we do this, then du is cos theta. Obviously, there is a d theta part. And this 1 minus sine square theta over square root, it is also becomes cos theta. So again, it is a cos square theta, d theta. We have to integrate this. Now, we know a little bit of result from trigonometry, and this result follows like this. Cos 2 theta is equals to cos square theta minus sine square theta. So if you make some adjustments, then you can see that cos 2 theta simply stands for, in terms of cos theta, 2 cos square theta minus 1. And in terms of cos square theta, it becomes what? 1 plus cos 2 theta divided by 2. We are going to use this in our integration. So if we use this, our integration will become something like this: 1 plus cos 2 theta divided by 2 d theta. We have to integrate this part. And simply one part is d theta divided by 2, and the other part is similarly cos 2 theta divided by 2 d theta. This is our simple task if we have to manage it. Now, if we want to manage it, then it will become, see, it will become theta by 2, and it will become sine 2 theta divided by 2 and 2, it is 4, right? So it is 4. Now if we do it from here to here, we can write what is theta. Let me back somewhere there and see what is theta. We calculate u equals to sine theta. So what is theta? Theta is sine inverse u, right? Theta is simply sine inverse u. So we can write that it is sine inverse u divided by 2 plus. Now expand sine 2 theta. If we expand sine 2 theta, it results as 2 sine theta cos theta divided by 4. Then 2 cancels out and it results as sine theta cos theta divided by 2. Okay, this is our result. Now if we want to make some little more adjustments towards this, then our adjustments becomes, we have to put all the terms in terms of x, right? In terms of x, u is x minus 1. So sine inverse u, let it be there, and let it place the main thing. Sine theta is u and cos theta is root under 1 minus u square, right? Am I right or am I wrong? Let's check there. U equals to sine theta, so cos theta is root under 1 minus u square in terms of that, right? I hope you people understand that, because as sine theta is u, so cos theta will be root under 1 minus u square. Now in terms of x, it becomes sine inverse x minus 1 divided by 2 plus x minus 1 in terms of root x minus 1 into root under 1 minus x minus 1 whole square divided by 2, right? But we have to do this integration in the limit 2 to 0. So again, come back to our main thing. Our main goal is to integrate this whole thing in the limit 0 to 2, right? That is our main goal. We want to integrate this guy root 1 minus x square x minus 1 square dx in 2 to 0, 0 to 2. So now we are going to put those limits in our functions. So if I put those limits, what are my functions? What are my results? My results are something like this. Sine inverse x minus 1 by 2 and this guy. So now I will put this limit and it will look like this. So sine inverse x minus 1 by 2 minus x minus 1 root under 1 minus x minus 1 square divided by 2, and we have to calculate this whole limit in the part 2 to 0. So now if we calculate, if we put 2, I hope I write it perfectly, right? Let's check again. Oh sorry, there is a plus sign, I mistook it. Sorry, it is will be plus. So if I put the value 2, so sine inverse 2 minus 1 by 2, that is sine inverse 1. Sine inverse 1 gives pi by 2, so it is pi by 4, and this thing simply becomes 0, so it is 0, so it will not there. Again if we put 0, this guy again becomes 0, so there is no function of this part. If we put 0 here, then it becomes sine inverse minus 1, it becomes minus pi by 2, but there is a minus sign also before, and so there is pi by 4. Pi by 4 plus pi by 4, it becomes pi by 2. This is the area of the blue part. Okay, we will make choice of it again, but let us do the rest of the things too, because those parts are also important. And for those part, let me change my color of the pen first. Okay, now let's do the rest of the part, and our rest of the part integration is again from 0 to 2. We have to do the integration 0 to 2 from, and our this time our guys are cos inverse 1 minus x minus pi dx. We have to make some choices here. So now if we make some good choices, then we can write cos inverse 1 minus x as pi minus cos inverse x minus 1 minus pi dx. In this way, this pi and this pi simply cancels out. So we are left with minus 0 to 2 cos inverse x minus 1 dx. Now if you peoples do the integration of cos inverse x, we will all know that this is a standard integration and there is a standard formula to do this integration. So if you people do this results as simply like this. I will write down the result for you peoples, but you people can check it by doing the by parts process. X minus 1 cos inverse x minus 1 minus root under 1 minus x minus 1 whole square. Okay, and this is the main part. Now we have to put the limits 2 to 0. If we put the limits 2 to 0, then what we can find? Check. If you look closely, then see, if we put the limit 2, that's 2 minus 1, that is 1, and this is minus there, there's a cos inverse 1, right? Again this part is 0. Now if we put 0 here, then there is a minus 1. Also there is a minus part, so plus, and the cos, as cos inverse also absorbs the minus part, so it will becomes cos inverse 1, cos inverse minus 1. Okay, and this part is again also 0. So now we are left with simply minus of cos inverse 1. Cos inverse 1 is what? Cos inverse 1 is 0, right? Cos inverse 1 is always 0. And what is cos inverse minus 1? What is cos inverse minus 1? When cos becomes minus 1? Usually when at x equals to 0, cos becomes 1. But when at x equals to pi, cos becomes minus 1. Right? See, the graph of cos is decreasing. And when x equals to pi, cos becomes minus 1. So cos inverse minus 1 is pi. So this is minus pi. Okay. So if we calculate the total area will be something like this. 2 into first part, our blue part, that is pi by 2, and the 2 into the red part, that is the modulus of minus pi. As we know that area will never be negative, so 2 pi. So our total area will become 3 pi. Okay, so we find that area of the heart is 3 times pi. That is an irrational number. I hope you all like the video. Please do like, share and subscribe. Thanks to